Hello friends, welcome to EPG Pathshala. I am Dr. Ramaswamy Prasad from Department of Geography, Dr. Bhimrao Ambedkar College, University of Delhi. Today I am going to elaborate upon the constitution of the Earth's interior, which comes under the paper Geomorphology. First of all, let us discuss what could be the learning objective of this module. While going through this module, you will be able to understand the changing conditions of temperature and pressure in the Earth's interior. Explain the density variations with increasing depth from the Earth's surface. Describe the propagation of earthquake waves. Infer the state of rock based on waves propagated. Explain the regions of varying conditions in the interior and comprehend different layers of the Earth's internal parts. Let us begin with the introduction. The interior of the Earth is that portion which is possibly not reachable for us. The part from where the sample is not supposed to be taken in our hands are difficult to understand very well directly. You must have seen the vendors selling watermelon on roadside who used to get a slice out of it. We can see the quality of watermelon by our own eyes, or even we can test the same before buying. Our Earth is not like the watermelon from where we can get the sample slice to study in detail. Constitution of the Earth's interior is the study of to understand the internal part of the Earth. In terms of the real conditions existing there, these conditions could be about the state of rock or temperature or pressure or the chemical composition of the rock at various depths. The study is facilitated by different branches, disciplines of the modern knowledges, like in general and physics, chemistry, seismology in particular. Let us study them systematically in detail. Now, meaning of composition and structure. In a very simple term, the meaning of composition is what something is consists of. In other words, it is unit of different parts for making a total. When we are referring the composition of the Earth, we are supposed to study the Earth with respect to the material of which it is composed of. The material is Earth's surface are different than the interior. By material, we generally denote about different kinds of rocks occupying different volume and mass it has. It includes the physical state of rock, density, temperature, or even the pressure they are bearing at different depths. A structure is something to do with the overall assemblage of an object. In other words, it is the unified total made up of different parts. When we are referring to the structure of the Earth, we are supposed to study the Earth with respect to the parts making the total. The arrangement of different parts of the Earth give a clear picture of the whole of the Earth. Therefore, the structure of the Earth is the way different parts are put together to get the plan or design of the Earth. Now, studying the Earth's interior, the real sample is not possible to get from the Earth's interior. Even if the internal material is ejected or received, provides a different conditions at the Earth's surface, the material's temperature or the pressure recorded in the interior is different in comparison to when it comes to the surface. Therefore, to study the Earth's interior, we have to take the help of two artificial sources, A, artificial sources, and B, natural sources. Let us talk about the artificial sources. Artificial sources are those sources which are basically derived from the mathematical assumptions and calculations. Important among them are density, pressure, and temperature. Let us study about the density. The density is made up of various types of rocks. Rocks are composed of minerals. Rock may be composed of one mineral or many minerals. The characteristics and properties of the minerals determine the rock. The rocks of various places are not alike, but are different. The rocks lying in our agricultural field is different from the mined rocks. It could be different type like igneous or sedimentary or metamorphic. In other words, it is defined as the relationship between the mass of the rock and how much volume it occupies. Thus, a rock with greater mass and lesser volume will become denser, but when the mass is less and the volume is more, its density is lower. Therefore, density is equal to the mass of the rock divided by the volume. By this formula, the result received is expressed as that much of gram per centimeter cubic. Probably for the first time, British scientist Henry Cavendish in 1798 attempted to calculate the density of the earth on the basis of Newton's law of gravitation. He found it to be 5.46 gram per centimeter cubic. The density of the rock found at the surface is 2.7 to 2.9 gram per centimeter cubic. The density of rock found at the sea floor is around 3 gram per centimeter cubic. It is quite obvious that the central part of the earth is more than 5.5 gram centimeter cubic. The average density of the earth is 5.52 gram per centimeter cubic. The density calculated at different depths in the interior of the earth is given in the following table 1. It is also very clear through this table 1 that the density of the interior part of the earth is around 13 gram per centimeter cubic. The increase in density in interior of the earth is not a continuous affair, but changes very abruptly at different depths. The changing density at different depth in the interior may very clearly be seen at a place through figure 1. Let us study about the pressure. It is quite obvious that the density of rocks lying in the interior is greater. It is scientifically proven that the density of the material is increased when it is compressed. Earlier it was estimated that the density of the interior rock is greater due to increasing pressure of the rock lying above. To some extent this assumption is true, but it is also universally proven fact that the density of the rock cannot be increased beyond a certain limit simply by compression or more pressure. Hence, the inference that the increasing pressure is the reason for greater density is not true. The higher density material of the interior can be explained through the constituent of the rock. It is now confirmed that the core is composed of essentially heavy metallic materials which have higher density. The pressure in the interior keeps on increasing with depth. You can see the figure number 2. Now, let us see about the temperature conditions. With the advancement of technology and know how to use the minerals, the mining activities started. We have been digging the earth since many centuries, but the deeper mining and oil exploration has led drilling the crust to much deeper level in the recent time. Our own observations record a rate of increase in temperature, and it is about 3 degrees Celsius per 100 meter depth, or about 30 degree Celsius per kilometer. If we calculate the temperature at this rate, the earth's core would witness a temperature of more than 1,90,000 degrees Celsius. It is unimaginable. Probably this much of high temperature would melt the entire earth. The above calculation has not taken the increasing pressure into account. A recent experiment conducted and calculated by the scientists suggests that the inner part of the earth core has about 5,000 degrees Celsius temperature with a variation of 500 degrees Celsius plus or minus. Hence, these two temperatures are contradictory to each other. The increase in temperature observed in the top layer of the earth is not constant. The rate may be higher near the surface for a few kilometers, but it is not true for the much deeper part of the earth. The rate may be higher near the surface for a few kilometers. It is not true for the much deeper part of the earth. The above conditions could very well be explained by presence of radioactive minerals in the top layer of the crust. Granitic rocks are very well known for the abundance of radioactive minerals like uranium and thorium. The higher temperature in granitic layer found is accounted due to chemical disintegration. The process of fission and fusion of these minerals generate huge amount of heat. This leads to greater temperature in this zone of the earth's strata. With increasing depth, the availability of radioactive minerals is less and hence lesser temperature. Therefore, there is decrease in rate of temperature with depth. Let us study about the relationship of density, pressure and temperature with depth. We have already deliberated about the density, pressure and temperature in the earth's interior. From these discussions, it is quite clear that all the three components are increasing with increasing depth. Their increase is not uniform continuously, but with changing rates. The reasons for their increase is already explained while dealing with those components. Let us study about the natural sources. There are two components of natural source to probe the earth's interior. They are volcanicity and seismicity. Let us study about the volcanicity. Volcanicity is a process within which fracture or fault is created by endogenetic force. Through these fractures or fault, magmatic materials, gas, vapor or rock fragments are brought to the surface. The ejected material or lava is very hot and it is the part of the rocks in the melted form. Appearance of melted material provided an idea that a permanent magma chamber is existing in the lower part. Scientists have also proved that increasing pressure in the interior also increases the melting point of the rocks. Hence, there may not be a permanent magma chamber. Even know very well that food is cooked very quickly in the pressure cooker than in open pot. In an open pot, the water gets boiled at a much lower temperature, that is 100 degrees Celsius, in comparison to pressure cooker where the temperature is 121 degrees Celsius. The vapor generated in the pressure cooker is not easily allowed to escape. It keeps on accumulating inside. Accumulation of vapor increases the pressure inside. Increase in pressure forces the water to boil at a much higher temperature. This experiment suggests that the increasing pressure is the cause of boil water or melt rock at a much higher temperature. Scientists suggest that there is no permanent magma chamber. Magma is generated because of removal of the overlying rock pressure. Overlying rocks are removed by shifting of the rock mass due to faulting. Once magma is generated, it becomes larger in volume. Since there is no vacuum space inside, magma pushes the overlying rock and breaks. The volcanism is the result and it appears on the surface. Therefore, volcanicity is also not much of great help in understanding the interior. Let us study about the seismology. Seismology is a branch of scientific knowledge to study the earthquake and its propagated waves. An earthquake is a sudden vibration of shake of the ground of the area due to abrupt breaking of a part of a plate, causing instability in this region. These lead to earthquake waves. The earthquake waves are recorded by an instrument known as seismograph. It is important to mention here that seismology is the only source by which entire earth could be probed. The probe provides authentic and complete information about all parts of the earth. Earthquake gets its birth from the depth below the earth's surface. This depth could be anything from a few meter to hundreds of kilometers. According to United States Geological Survey, the scientific purpose, the originating depth of an earthquake may vary from 0 to 700 kilometers. The point from where the earthquake originates is known as focus. Epicenter is the shortest distance from the focus to the earth's surface. It is perpendicular distance exactly above from focus. Epicenter is given in figure number 5, being the closest place on the earth surface experiences the earthquake first. It is recorded later to the distant places from the epicenter. Principally, there are three types of seismic waves. First, primary waves, second, secondary waves, and third, surface waves. They are recorded one after the other by the instrument. Let us study about the primary waves. Primary waves are known as compressional waves. They are also termed as push and pull waves. It is given in figure number 6. It is like sound waves that we hear. The sound generated from the source pushes the air available nearby and it keeps on hitting the adjacent air molecules. In this way, the sound reaches to our ear and we hear. Earthquake occurs due to plate movement and breaking of the plate edge. Thus, generated pressure pressurizes the surrounding rocks. This pressure keeps on moving further and are recorded by the seismographs installed at different places. The force with which we hammer the nail goes inside, but with the same force hammer is returned backward towards us. This gives a back and forth or forward and backward movement of the quake waves. Let us talk about the characteristics of the primary waves. It is the fastest wave, hence it reaches the surface first and get recorded in the seismograph. It travels in all three states of matter: solid, liquid and gas. Its velocity is greater in solid, less in liquid and very slow in gas. Its velocity increases if there is increase in the density of the rocks and vice versa. Once the state of matter changes from the solid to viscous or liquid, its velocity decreases even if the density is greater. The velocity of P waves varies from 5.5 km per second at or near the surface to 13 km per second in the deep interior. Let us talk about the secondary wave. Secondary waves are known as transverse waves. These waves travel at right angle to the direction of the wave propagation. These waves seem to be like the light waves. These type of waves are just like waves on calm water of the pond when we throw a pebble. It can be seen very clearly from the figure 7. Since these waves are travelling with horizontal movement at the surface, they are more dangerous than P waves. Let us talk about the characteristics of the secondary waves. Its velocity is less in comparison to primary waves, hence it is recorded after P waves on the seismograph. It reveals only through the solid state of matter. Its velocity increases if there is increase in density of the rocks and vice versa. Once the state of matter changes from solid to viscous, its velocity is reduced, but when the rocks are melted, it disappears completely. The velocity of S waves varies from 3.25 km per second at or near the surface to 7 km per second in the interior. Let us talk about the surface waves. Surface waves or longitudinal waves travel through the Earth's surface. Earth's surface waves are manifestations of the P and S waves which finally reaches at the surface from the interior. These waves travel in the same way as if you are giving jerk to the wet towel before spreading on a rope. They are categorized into two Love waves. It is named after A.E.H. Love, and Rayleigh waves. It is named after J.W.S. Rayleigh. Love waves, which is given in figure number 8, travel in both horizontal and perpendicular direction of the wave propagation. The particles motion in Rayleigh wave, that is given in figure number 9, is in elliptical motion, generally retrograde in the vertical plane and parallel to the direction of the wave propagation. Let us see about the characteristics of the surface waves. Its velocity is less in comparison to primary waves and secondary waves. Hence, it is recorded after P and S waves on the seismograph. It travels only through the solid state of matter. The velocity of L waves varies from 2 to 4.4 km per second, while the velocity of R waves is slightly less from 2 to 4.2 km per second. The velocity of L and R waves is dependent on the frequency of waves as well as their penetration in the upper layer of the earth. Now, let us talk about the interpretation of the propagating of different waves. As mentioned before, all seismic waves start propagating with the occurrence of earthquake simultaneously, but they are recorded at different times on the seismograph. Its region is different velocity at different waves. The faster moves reaches quickly, but the slower wave reaches after a time lag. Look at the figure number 10 given below. It is showing the concept written above. In the initial stage, the strain and stress operating on the rock produces very faint noise and probably experienced by some sensitive animals whose bodies or nose are near the surface. They get frustrated and behaves very differently. After this, P wave arrives. As it is the fastest, S waves takes a little more time to reach the same place because of slower velocity. The difference between the arrival of P and S wave is known as time lag. It is given in figure number 10. The duration of time lag depends on the distance between the epicenter of the earthquake and the referred place or measuring station. Nearer place would observe a smaller time lag, whereas far distant places would observe bigger time lag. At the epicenter, probably it is difficult to identify time lag because of less gap, or practically speaking no time lag between P and S waves. Let us discuss about the seismology and constitution of the earth's interior. The waves generated at the time of earthquake occurrence radiates in all directions from the focus. The radiated waves are not passing in a straight line, but follow curved paths. Curvature of the paths due to changing density from the earth's surface to the core. Due to refraction of the waves, S wave are not found beyond an angular distance of 105 degree from the epicenter of the earthquake. In the same way, P waves are not traceable from 105 degree to 140 degree from the epicenter. These are known as shadow waves. It is given in figure number 11. But more important about the interior of the earth is revealed by nature of the propagation of waves, particularly P and S, from the surface of the earth towards the interior. Both P and S waves propagating with increasing velocity. Approximately at an average depth of 40 km, there is increase in velocity of both waves. It suggests that there is sudden increase in density of the rock at that depth. At a depth of around 100 to 250 km, the velocity of both waves starts declining, and after around 700 km, velocity again becomes greater. The decreasing velocity in this belt indicate that the matter of rock is semi-solid. Because of this, velocity of both waves declines. This low velocity zone is known as asthenosphere. It is also named as transition zone. Further beyond the velocity of both waves increases continuously until a depth of around 2900 kilometer. Increasing velocity shows that the density is higher and state of the rock is solid. From 2890 kilometer to 2900 kilometer, the rocks are again almost in plastic state, that is neither solid nor liquid. This narrow belt is called as D layer, which is condition of a transition zone. It is given in figure number 11. Beyond the depth of 2900 kilometer, there is no trace of S waves and the velocity of P waves declines very drastically. Remember the characteristics of both waves. It suggests that the rocks at the depth is melted. S waves does not travel in liquid. Reduction in the velocity of P waves is also due to the changing state of the matter or rocks. At around 150 kilometer depth, the velocity of the P waves increases. This is a proof that the rocks becomes solid again. Chemical composition of the earth. There are three major and almost concentric layer of the earth. These are explained by Swiss and they are Sial, Sima and Nife. Sial, it is the topmost layer of the earth found just below the sedimentary thin cover of the crust. Silicon Si and aluminum Al are the very important elements found in abundance in this layer. They are named as Sial, Sial. The average density of the layer is 2.75 to 2.9 gram per cubic centimeter and its average depth is 40 kilometer. It is very thin below the oceanic water, that is 5 to 10 kilometer. Just below the mountain, it is a thickness of around 70 kilometer. The main rock in this zone is granite. Let us talk about Sima. It is the second layer after Sial from the surface towards the interior. It is named after silicon Si and magnesium Ma. As both of these elements are very much abundant in this layer, it is a very thick layer which goes almost up to a depth of 2900 kilometer. It starts from a depth of around 70 kilometer below continents, while below the oceans it is found at 5 to 10 kilometer depth. Its average density varies from 2.9 gram per centimeter cubic to 4.75 gram per centimeter cubic. The main focus in this layer is silicate of magnesium and iron. This layer is highly composed of basalt. Let us talk about Nife. It is the innermost layer of the earth. This layer is made up of nickel Ni and ferrous Fe, and so it is named as Nife. It is just below the Sima from the depth of 2900 kilometer to the earth's center, encircling from all directions. Nickel and ferrous are found here. They are very heavy and denser elements. Therefore, this layer have higher density. Its density is about 11 to 12 gram per centimeter cubic. It is believed that the existence of nickel and iron in the Nife is the main cause for Earth's magnetic properties. Let us discuss about the Earth's internal structure. The study of propagation of seismic waves in the interior enabled the scientists to theorize about the structure based on the abrupt changes in the parts of the seismic waves. They are crust, outer and a very thin layer of the earth crust, mantle, an intermediary thick layer with large volume of the rock below the crust and core. The innermost layer, which is spread all around the center of the earth. Let us talk about the earth's crust. The earth's crust is the outermost and thinnest layer with an average depth of 5 km below the ocean and about 40 km below the continents. Its depth reaches about 70 km below the mountains. Apart from a very thin sedimentary layer on the continental crust and adjoining ocean floors, it is primarily composed of igneous and metamorphic rocks. Its lower limit is very clearly marked. Both P and S waves increases due to abrupt change in density. At the lower limit of the crust, the velocity of waves is 7 km per second, which increases to 8 km per second immediately entering the mantle. Lying below, the same thing is happening with the S waves, where it is 3.7 km per second in the crust, but it increases to 4.5 km per second after the boundary. The density of the crust at the surface is 2.7 gram per centimeter cubic, and at the bottom limit it is 2.9 gram per centimeter cubic. The demarcating limit is known as Mohorovicic discontinuity, from where mantle starts. Let us discuss about the mantle. Just after the upper layer, the density of the mantle of the boundary increases to 3.0 gram per centimeter cubic, from where the velocity of both P and S waves increases very significantly. As mentioned in the above paragraphs, the increase in velocity of seismic waves is due to increased density existing there. It extends from the base of the crust to about 2900 km below the surface, which is given in figure number 12. It occupies over 80% of the earth's volume and 65% of the total mass of the mantle is composed of ultramafic rocks. It is igneous in nature and very rich in minerals. It is composed of magnesium and iron with very low silica content. The chemical composition of mantle is almost similar throughout, but there is change in temperature and pressure inside. With increasing depth, the physical properties changes and therefore, the behavior of the rocks also changes accordingly. Roughly up to a depth of 100 to 250 km from the surface, rocks are firm, solid and rigid. Below this depth, the state of the matter is partially molten and plastic in behavior. This plastic and semi-solid belt extends about a depth of around 700 km. Let us discuss about the lithosphere. It is a top upper solid and rigid layer of the earth. Its depth varies from 100 km to about 250 km, below which the matter is in semi-solid state. Therefore, lithosphere consists both upper solid part of mantle and entire crust. Complete solid upper part of the earth is divided into several plates, of which the surface is made up of, including both continent and ocean. Let us study about the asthenosphere. The term asthenosphere is derived from the Greek word asthenos, meaning weak. Therefore, this literal meaning is to denote the layer which is weak. In terms of fluidity, geologists believe that the asthenosphere is semi-solid. It is composed of silicate of iron and magnesium. The overall consistency is just like hot tar, the material used to make black road top. Its depth is about 100 kilometer to 700 kilometer. Both webs P and S slows down while propagating through this layer. This clearly suggests that this layer is not fully melted, as S waves is not stopped, but passes with lower velocity. Both asthenosphere as well as the solid upper portion of the mantle together are known as upper mantle. Let us talk about the lower mantle. The concentric layer from a depth of about 700 kilometer to about 2900 kilometer is solid. In this zone, the velocity of both waves P and S increases abruptly until it reaches a depth of 2900 kilometer. Beyond this depth, the velocity of P waves decreases very drastically from 13.7 kilometer per second to 8.4 kilometer per second, and S waves disappears completely. It clearly suggests that at this depth the state of matter is liquid or in molten form. That at this depth the state of matter is liquid or in molten form, as S waves is not entering. This distinct characteristics is defined by a boundary between two dissimilar sections. It is known as Gutenberg discontinuity. It is referred as core mantle boundary, that we generally refer by CMB. Let us talk about the core. It is the innermost layer of the earth, starting from the Gutenberg discontinuity to the center of the earth. It is completely spherical in shape. It has a volume of only 17% of the earth, but it contains 34% of the mass. It is because of very high density of the material existing there. The density of core at the Gutenberg discontinuity is 5.5 gram per centimeter cubic, whereas the density of the core near the boundary is about 10 gram per centimeter cubic. The core is made up of iron and nickel. Both of them have lower melting temperature than the material lying above. As mentioned in the above paragraphs, the disappearance of S waves and abrupt reduction in the P waves propagation lead to conclude that the material is in liquid state. The liquid state of matter is recorded till a depth of 5150 kilometer. After this depth, it is in solid state. Here the velocity of P waves increases. It is solid because the pressure is excessive high and the melting temperature is increased, but the temperature needed to melt is lower than the temperature at that pressure. The interior of the earth is thousands of kilometers deep and directly inaccessible. Therefore, direct method of study is impossible. Based on the principles of the science and their derivations, interior is studied indirectly. In a very conclusive manner, it can be said that the temperature, pressure and density are increasing with increasing depths. The nature of the materials is changing. The surface is made up of such materials which are lesser in density. The materials constituting the surface rocks are different than that of the interior. Based on the chemical constitution, interior is classified into 3 layers: Sial, Sima and Nephe. Seismic waves are the only source to reveal the interior. Depending upon the propagation of P and S waves in the interior, 3 very distinct layers, crust, mantle and core, are identified with distinct separating boundaries. Thank you.